Hello everybody, I'm Syed on Maths Online. The last video we're discussing a few problems based on random variables. We'll continue with a few more problems on the random variables. So the question is, the probability distribution of a finite variable x is given by the following table. The values of x and the probabilities are given. We need to find the value of k, mean and variance. As we know that for probability distribution, two conditions has to be satisfied. The first condition is p of x should be greater than or equals to 0. So we try to observe here the values of p are positives and k value, if it is greater than 0, then this condition will be satisfied. Then the second one, then summation of p of xi or p of x should be equals to 1. That means when you sum up all these values, it should be equals to 1. So let us use this condition and find out the value of k. So if you sum up, it will be 0.1 plus k plus 0.2 plus 2k plus 0.3 plus k is equals to 1. Let's try to add it. It's 0.1, this is 0.3 and this is 0.6 plus k values. It's k plus 2k plus k. It is 4 times of k will be equals to 1, or 4k will be equals to, it is 1. Take this 0.6 on the other side, becomes minus 0.6, or 1 minus 0.6 is 0.4. So we get 4k is equals to 0.4, or the value of k will be equals to, it is 0.4. This cross multiply is divided by 4. So we cancel out, the value of k will come out to be 0.1. So now if you try to plug in this value of k back over here in the table, you can rewrite the table as xi and p of xi. So the values are minus 2, minus 1, 0, 1, 2 and 3. So first value is 0.1 as it is. Next value is k is 0.1. The next value is again 0.2. The next value is 2k. So 2 times of 0.1 will be 0.2. Then 0.3 and the k value is 0.1. So completed the table. So using this, we need to find out the mean. So mean mu is equals to, so the formula that we have is summation of xi into p of xi. That means you need to just multiply this one, x into p of x. So if you try to multiply, the first value that we have is minus 2 times of 0.1. So x into p of x, first value. Again x into p of x, it is minus 1 into point of 1. Then plus 0 into anything will be 0. Plus 1 into 0.2. Plus 2 into 0.3 plus 3 into 0.1. Just try to calculate this value and see what you get. Are you getting the value as 0.8? Then it is right. Then we need to calculate the variance. Variance v is equals to, I have given you two formulas, so I will be using one of the formulas, that is summation of xi square into, it is p of xi minus of mu square. So let us try to plug in the values over here. So variance v will be equals to, so you have to square x and multiply that by p of x. So x has to be squared over here. Square this value of x and multiply with p of x. That is what we have. So just see the table and try to complete this one. So x value, first value of x is minus 2 and it is squared into p of x value is 0.1. because summation is there, you need to add. Next value of x is -1, it is squared into p of x is 0.1. The next value of x is 0, so 0 into anything will be 0 itself. Next value of x is 1, so 1 square into p of x value is 0.2. The next value of x is 2, so 2 square into p value is 0.3. The next value is 3 square into p of x value is 0.1. So we have plugged in all the values of summation of xi square into p of xi minus, you have mu square, so the value of mu over here is 0.8, so it's 0.8 square. You can just evaluate this one and see what will be the solution that you'll be getting. Are you getting it as 2.16? Then it is right. So that completes the problem. The second question is, random variable x has the following probability function for various values of x. So the values of x and p of x are given. We need to find out k. We need to evaluate probability when the value of x is less than 6, probability when the value of x is greater than or equals to 6, and probability when the value of x lies between 3 and 6. Also we need to find the probability distribution and the distribution function of x, which is nothing but the cumulative distribution. So for probability distribution, two conditions has to be satisfied, that is p of x should be greater than or equals to 0. And the second condition is that the summation of p of xi or p of x, you can take it, p of x to be equals to 1. So if you sum up all the values of p of x over here, you will be getting 0 plus k plus 2k plus 2k plus 3k plus k square plus 2k square plus 7k square plus k is equals to 1. So let's try to add over here. This is k, 3k, and there is 5k, and this is 8k, and there is 9k. So 9 times of k plus you have k square values. This is k square and this is k square and that is k square. So how many times? It is 10 times of k square. So let me write 10 times of k square. That is 9k. So we have 10k square plus 9k is equals to, it's 1. Or if I take 1 on the left hand side, I get 10k square plus 9k minus 1 is equals to 0. If I try to solve this one, the value of k will be equals to 1 by 10 and the value of k will be equals to minus of 1. But since we have this condition that p of x is greater than or equals to 0, so for this the value of k should be positive. So this case cannot be considered. So you have to take the value of k to be positive, hence we get the value of k as 1 by 10. So now if you try to plug in this value of k back in the table, so the table now becomes x and it is p of x. You have it is 0, corresponding value of p is 0. You have 1, the corresponding value of k is 1 by 10. Then you have 2, the value of k is 1 by 10. So 2k will become 2 by 10. It is 2 by 10. Then it is 3, again it is 2k, it is 2 by 10. Then you have 4, it is 3k, it's 3 by 10. Then you have 5, then the value of p is k square, so it is 1 by 10 whole square will become 1 by 100. It is 6 by, it is 2k square, that is 2 by, that is 100. Then you have 7, then it's 7k square plus k, so it is 7k square plus k, that's the value you have. So if you try to simplify, it is 7 k square will be 1 by 100 plus the value of k is how much? The value of k is 1 by 10. You just take the LCM as 100 over here, so this will be 7 itself plus 10 times of 1, so it is 10 times of 10 will be 100, so 10 times of 1 will give you 10, so therefore we will be getting 17 by 100. So this value will become 17 by 100. So we have got the values of x and p of x. Now we'll try to evaluate this value. Evaluate probability when the value of x is less than 6. So x is less than 6 means you have to take all the values of x less than 6. So these are the values of x: 0, 1, 2, 3, 4, up to 5 you can take, because it is less than 6, so 6 cannot be included. So you have to take the values from 0 to 5. So this p of x less than 6, that will be equals to p of 0 plus p of 1 plus p of 2 plus p of 3 plus p of 4 plus p of 5. So we'll be taking from 0 to 5. So all the values are known from the table, so you can try to see this values. You are having p at x is 0, at 1, at 2, 2, at 3, at 4 and 5. So you need to just add all these values over here. So p of 0 is 0, p of 1 is 1 by 10, p of 2 is 2 by 10, p of 3 is again 2 by 10, p of 4 is 3 by 10, p of 5 is 1 by 100. You can just try to evaluate this value. So just check whether you get this value to be equals to say 81 by 100 if you take the LCM as 100, or you can rewrite this as 0.81. So that's the solution you'll be getting. The next value that you have is you need to find out probability when the value of x is greater than or equals to 6. That's the next question you have. So for greater than or equals to 6, because equals to 6 is there, 6 should also be included. So you have to take 6 and 7. These are the two values, equals to 6 and greater than 6. So you get probability of 6 plus probability of 7. So you have got probability of 6 to be equals to 2 by 100. Probability of 7 you have got 17 by 100. So just try to add, take the LCM. So just this 2 plus 17, which is nothing but 19 by 100. The next probability that you have is probability when 3 is less than x, x is less than or equals to 6. Then you have to take the values of x lying between 3 and 6, because 3 is less than is given, equals to is not there, so you cannot take 3. So after 3 you have 4. Next is 5, and because equals to 6 is there, you have to take 6. So write down p of 4, we know the value is 3 by 10. P of 5, its value is 1 by 100. P of 6, its value is 2 by 100. So we just take the LCM as 100. So here we'll be getting 30. Here it is 1 and it is 2. So we'll get 33 by 100. So the distribution function of x will be distribution function of x is represented by f of x, and I have already given you the formula earlier. Its value is probability when the value of x is less than or equals to small x. It is nothing but it is summation p of it is xi, where the value of I is running from 1 to x. This is nothing but the cumulative distribution. This formula is for cumulative distribution. So now if you try to prepare the table for the values of p of xi, for cumulative distribution you can write the value of x and f of x. So when x value is 0, then And what is f of x? That means you have to write down the values of p of x, sum of the values of p of x. So total number of values of p of x that you have is from 0 to 17 by 100. So just for convenience, you can even write 0 as it is. That is 1 by 10 can be written as, say, 0.1. So let me rewrite it. It's p of x. This will be 0 itself. 1 by 10 can be written as 0.1. 2 by 10 can be written as 0.2. Again 2 by 10 is 0.2. 3 by 10 is 0.3. 1 by 100 is 0.01. 2 by 100 is 0.02. And 17 by 100 is 0.17. So it just becomes easy for us to add. Now coming to this value of f of x. So the first value of f of x will be 0 itself, no change. For the next value of x is 1. Then the corresponding value of f of x will be the sum of p of x values. So 1, so all the values starting from 0 to 0.1, so 0 plus 0.1. So it comes out to be 0.1. Next x value is 2. So f of x value will be all the values from 0 to, so this 0.2. So this previous two values we already added, plus the present value. So the previous value you already have added it, plus the present value. It gives rise to 0.3. Next we have 3. Then you can take the previous sum value is already 0.3, plus the present value that you have is 0.2 itself. So it gives rise to 0.5. Next 4, the previous set of values are 0.5, plus the present value is 0.3. It gives rise to 0.8. Next we have 5. The previous sum value is 0.8, plus at 5 it is 0.01. That gives rise to 0.81. Next, when the value of, say, x is, next value of x is 6. So when x is 6, what about f of x value? So the previous sum value we already have 0.81, plus the present value of p of x for 6. For 6 p of x is 0.02. So it gives rise to 0.83. The next value is for 7. So the previous sum is 0.83, plus the present value is 0.17. It is 0.17. So if you try to add it, 0.83 plus 0.17, it comes out to be 1. Alright. So summation of p of x, we know it's 1. So the final value we got it as 1 over here. That's all we have for today. Thank you.